Okay, so now we are on page 7 of the just-in-time review note outlines, and we left off finishing the first technique of factoring, and I'm just going to say again that the factoring part of this section is by far the most important topic that you need to know how to do. So you need to know that first technique that we already did, which was factoring out the greatest common factor on page 6. That was technique 1. And now we are going on to the second technique. And in order to do this technique, we need to be good at the first technique. So that's why they're each important, because they build upon each other. So the first technique that we already did was factoring out the GCF, the greatest common factor. Technique 2 that we're going to do now is called factoring by grouping. This technique applies to some polynomials that have 4 terms. And in the box are all the general steps to completing this technique. So step 1 is factor out the GCF, if there is any, just like we did on page 6. Step 2 is imagine the first 2 terms kind of grouped together. Now, it might be kind of a weird word to put into a math discussion, like, oh, just imagine these 2 together, but that's really what you want to do. There's a big mistake that people make when doing this technique, and they don't just imagine it, they actually put parentheses around the 2, which is not what you want to do. So that's this part here. I'm just going to say that important here, do not put parentheses around that pair. A lot of people do that, and it's not correct. So you're just going to want to imagine the first 2 in your head. Imagine the first 2 terms grouped together, as well as the second 2 terms grouped together. And then always be mindful of the signs of the monomials involved, meaning pay attention to whether they are plus, whether they're positive, or whether they are negative. And you should just always be doing that no matter what type of math you're doing. Pay close attention to whether terms are positive or whether they're negative. Step 3, factor out the greatest common factor of the first pair of terms and factor out the greatest common factor of the second pair of terms. So now you should hopefully be able to see why we had to do technique 1 first. It's because we're using it here in technique 2, the greatest common factor. Step 4. Once you do step 3, you're going to have parts that are kind of left over. That's what I call them, leftovers. The parts that are left over should be the same. A lot of people force them to be the same. Don't do that. Do step 1, step 2, step 3, and then take a step back and ask yourself, hey, when I did these 3 steps, did my leftover parts turn out to be the same? If they did turn out to be the same, then you're probably on the right track. And if they did not turn out to be the same, then go back, revise each step carefully, and see where you might have missed something. And so if they are the same, then that means you're going to be able to factor them out. So you'll factor out those leftover parts that are the same. So it's kind of, these 4 steps are kind of hard to understand exactly what's going on in them until we do an example. So let's just go ahead and do an example. So this example down here, factor the following expressions by grouping. So part A, when I read this, it says 3a squared plus ab squared minus 3ab minus b cubed. The first thing I'm asking myself is, how many terms are there? Well, we got 1, 2, 3, 4 terms. And remember, up here, I said that this technique applies to some polynomials with 4 terms. All right, now step 1 says factor out the GCF if there is any. So that's what I'm going to put down here in these parentheses. First thing you need to do is check for GCF. So if you look at those 4 terms, is there anything that all 4 of them have in common? The answer is no, so we're done with step 1. Now, move on to step 2. Step 2 says, imagine the first 2 terms grouped together. So for my whole imagine thing, I'm just going to put little dots under the first 2 to just tell myself these 2 are going to go together. And then it says in step 2, also imagine the second 2 terms together. So I will also put my little dots under those 2. So I am not putting parentheses. That's bad math. Do not do that. But just to tell myself that the first 2 go together and the second 2 together, I can put little dots underneath that because little dots don't mean anything in math, but they are just telling me which ones are going together. So we're already done with step 2. Step 3. Step 3 says, factor out the greatest common factor of the first pair of terms. So let's look at the first pair of terms, 3a squared and ab squared. And you ask yourself, do those 2 have anything in common? Well, I see that they both have an a in common. So I'm going to write a. And just like on page 6, I'm going to factor out that GCF and I put parentheses. And then I ask myself, I look at this first term, 3a squared. If I pull an a out of that, what's left? We will be left with a 3a. And then the sign next to it is plus. Move on to the second term. If we divide this second term by a, divide that a out, the a's go away and we're left with a b squared. So I'm going to put b squared. Close it. So we're done with the first pair of terms. Now move on to the second pair of terms and be mindful of the signs. So we have a minus 3ab and a minus b cubed. So we also ask ourselves, what do those 2 have in common? Well, they're both negative, so I'll put minus. And they also both have a b in common, so I'll put minus b. So we are taking a minus out of those 2 terms, and we're also taking a b out. So for this first term, if we take out a minus, it's going to become positive. And then if we take out a b, we're going to be left with 3a. So we just have a positive 3a left. Move on to the next term here, minus b cubed. We're taking the minus out to the front, so we'll be left with something positive, so I'll put a plus in there. And we're taking a b out. Well, if we take a b out of b cubed, if we divide that out, we're going to be left with a positive b squared, and close that off. So now we're done with step 3. Move on to step 4. What does that say? It says now the parts that are left over should be the same. And for me, my leftover parts, I'm saying are here. That's a leftover, and this was leftover. When we pulled the GCFs out, those were our leftover parts. And since they're the same, they're basically like a GCF, because if you look at this part as one big term and you look at this part as one big term, you can ask yourself, what do those 2 parts have in common? What does this first whole part and this whole second part have in common? What's their GCF? Well, they both have the 3a plus b squared in common. And just like we did on page 6, when we have our GCF, when we have something in common, we write it out to the front, and then we put parentheses, and then we write what's left over. So if we look at this first big part, this first expression here, if we take a 3a plus b squared out of that, what will be left? Just the a. So I'm going to write a. Then we move on to this part. If we take the 3a plus b squared out of this whole thing, what's going to be left over here? We're going to be left with the minus b. So I'm going to write that down, close it off, and we reached our goal. Remember, the directions said factor. And in math, a lot of people think that math is all numbers. But to me, the most important part of math is the words. You have to know what every single word means. You have to learn what add means. You have to know what subtract means. You have to know what factor means. So in this case, when we read the directions and the directions tell us to factor it, you need to know that that means, all right, I need to take this expression that I'm given, and my goal is to create multiplication out of it, which is what we did, because the answer that we just boxed here is an expression times another expression. So we took the expression that we started with, the 3a squared plus ab squared minus 3ab minus b cubed, and we converted it to something times something, and that's what factor means. Let's do another one. We're going to go through all 4 steps once again. So part B, first of all, look how many terms we have. 1, 2, 3, 4 terms. What's step 1? Step 1 says factor out the GCF if there is any. So that's what we're going to do. First, check for the GCF. So look at all 4 terms. Do they have anything in common? All 4 of them. They don't have a variable part in common, but they do all, the 6, the 18, the -3, the -9, those are coefficients. They're all divisible by 3. So that's the GCF. So I'm going to pull the 3 out of each of the 4 terms, and we're going to write what's left over. So when we pull the 3 out, we're just dividing each of the terms by 3. So if we do 6 divided by 3, we get 2, and then the x squared. If we do 18 divided by 3, we're going to get plus 6, and then the x. Over here, we get minus, if we divide the -3 by 3, we're going to get a -1x. And then lastly, if we divide -9 by 3, it's a -3. Be careful with your positives and your negatives. So that was step 1. We factored out the GCF. So on to step 2. Imagine the first 2 terms grouped together as well as the second 2 terms. So what I'm going to do with this 3, we're not going to worry about it the entire rest of the problem, but you need, in every single line that you write down, you need to just keep writing that 3 out in front. You don't want to just do part of it, write part of your work on over here and leave part of it behind. You need to be full out with your work every single line as you move your way down the page. So don't leave anything out. So we're on step 2, and we're not going to worry about that 3 out in front. It's just going to hang out in front the entire rest of the problem, and we're going to work on the part that's inside the parentheses. So remember that we imagine the first 2 grouped together. So these 2 terms go together, and then also these 2 terms go together. And this is really why it's called factor by grouping, is because we're kind of grouping the first 2 terms together and we're grouping the second 2 terms together. So we're done with step 2 now. Step 3. Step 3 says factor out the GCF of the first pair of terms and factor out the GCF of the second pair of terms. So let's do that. So here's our first pair of terms. Do they have a GCF? Do they have anything in common? they got a 2 in common, and they got an x in common. So I'm going to put 2x, then we put parentheses, and then if we pull the 2x out of this term, what's left? We're going to be left with an x, and then we got a plus sign. What happens if we take a 2x out of this term? Well, 6 divided by 2 is 3. And then we have an x, but if we divide out this x here, it's going to go away. It's going to cancel. So we're done. Close it off. Now move on to the other pair of terms. Do these two have anything in common? The only thing that they really have in common is a minus sign. And they're both, anytime they don't really have anything in common, you can always write a 1. So we're going to pull a -1 out of each of them. So basically, we're taking this minus out, we're dividing it out, so we'll be left with a positive x, and we're also dividing this minus out. So we'll be left with a positive 3. So close that off. That's step 3. Step 4. Step 4 says that the parts that are left over should be the same. Let's look. Here's a leftover part when we factored out the GCF, and here's the other leftover part. And just ask yourself, did they come out the same? Well, x plus 3, yep, that's exactly the same as x plus 3. So that means we're on a good track. So once we see that, what we always do with those leftover parts, the ones that are the same, the x plus 3, we put them out in front, like that. And again, you're just thinking of this as one big term and this as one big term. And you're saying, okay, what do they have in common? They have that x plus 3 in common. And so if we take the x plus 3 out of this expression, we will be left with a 2x. And then if we go over here and we're pulling the x plus 3 out in front from this expression, we would just be left with a -1. And we factored that. And again, remember, anytime you get an answer, box your final answer, first of all. Second of all, ask yourself, did I do what the question is asking me to do? Again, the question was asking us to factor, and we did that. We took this expression here for part B, and we changed it into multiplication. It's 3 times x plus 3 times 2x minus 1. And that's what it means to factor, is you take the expression and break it down into multiplication. And you can also check your answer. Check. You can check these answers by foiling them out. You can foil, for part A, foil that all out. Here you can foil these out, and then you would distribute the 3, and it should equal what you started with. Okay. So let's see. All right, that was technique 2, factor by grouping. And in order to do that technique, we had to know how to do the first technique, which was the factor out the GCF thing. Now we're going to move on to technique 3, which is the granddaddy of them all. This is one that I will definitely be asking you questions on, how to do for like the quizzes or the tests. So this one is called the AC method. There are other, I don't even want to call them techniques, but there are other ways that people do this that are not actually mathematically accurate. I am going to require you to do this technique in a mathematically accurate way, because I just don't think it's right to have students come into a math class and teach them mathematically inaccurate tricks. My responsibility to you is to teach you true mathematics. So follow along, and if you're unsure about anything, please come to office hours and talk with me so that we can just get it straightened out, and that way when you see it on the quiz or a test, you're like, okay, yeah, I learned this during office hours, I have it down like the back of my hand, okay? So factoring a trinomial, the AC method. So trinomial, we talked about binomial, I think in the last video, and which meant a two-term expression. Trinomial is a three-term expression. So there are basically an infinite amount of trinomials. This method works for certain trinomials. So trinomials are often in this particular form, ax squared plus bx plus c. That is also known as a quadratic form sometimes. So if we see a trinomial that's in that form, ax squared plus bx plus c, then it can be factored by using the AC method. So here are the steps for the AC method. Step 1, just like in the last technique, always look for your GCF. Factor that out if there is one. Then the GCF just hangs out in front the whole rest of the time. See, like this 3 did, remember? And you work on the rest of it. So step 2 is you take whatever A is and whatever C is, you multiply those together to get AC. Step 3, you find two numbers which multiply to AC and sum to B. Now make sure that you do this part first. If you think about the numbers that multiply to AC, and then ask yourself later if they sum to B, it's just more efficient that way. You're going to get to the correct answer sooner. Okay. So you're going to find two numbers that when you multiply them together, you're going to get AC, and then when you add them together, you're going to get B. Once you find those two numbers, move on to step 4, and you're going to break up the middle term, BX, and middle term meaning that, the BX. You're going to split that up into two parts. You're going to break it up using the two numbers that you found in step 3. Step 3. All right, once you do that, well, think about it. Look at this middle term up here, the BX. How many terms did we start with? We started with 3 terms. How many terms will we have if we split the middle term up into 2 terms? Well, then we'll be left with 4 terms. And remember the technique up here, technique 2, the factor by grouping was what we used when we had 4 terms. So then we're going back to technique 2 at this point. So step 5, factor this new polynomial by the grouping technique that we learned on the previous page, because now it'll have 4 terms and we go through that whole technique. All right, so let's do some examples of this. If you look at these big X's on the left side, you don't have to use them if you don't want to. They're just kind of like a visual aid if you like that type of thing. I actually didn't even use them for the first 25 years of my life. I started teaching at a different college and they used this little X device and I actually thought it was helpful, so I'm going to use it here. So it's just kind of like a little organizational device that you can use. So first of all, this is a trinomial, and it's of the form ax squared plus bx plus c. So that means we can use the AC method on it. So what's step one here? Step one says factor out the GCF if there is any. So we're asking ourselves, is there a GCF here? And there is no GCF. And by the way, as a side note, sometimes, you know, I'll ask you a question, or even if I don't ask you a question, always try to be ahead of me just a little bit, not too much, but just a little bit. Like always be actually trying to look for the answer, or always try to be looking ahead and being like, okay, how can I apply what we were just talking about to this example? What can I do? Just always be asking yourself that. Or if I ask you a question, actually try to answer the question in your head. Don't just sit there twiddling your thumbs and being like, well, she'll tell me. Because the more that you do it on your own, the more you'll be aware of like what your strengths and your weaknesses are and what you need to work on. And also, the more that you do it, the more times that you do that properly, or you know, that you get the answer correct, then your brain is forming those connections. And the more it forms the connections to how to do a particular type of problem, the easier it's going to come to you when you have to go do it on your homework. The easier it's going to come to you when you have to answer a question on a quiz. So you just want to form those connections as early on as possible. And one way to do that is to always already be trying to think about the math in your head before I tell you what the answer is. So anyway, back to this example. Is there a GCF? No, they don't have anything in common, so we're done with step one. Step two, multiply A and C together to get AC. So that's where I'm using this little X. I'm just going to put AC up there, and I'm always going to put B down there. So write out what A and B and C are. It's a really good habit to get into. A is 4, B is 9, and C is -9. Again, pay close attention to positives and negatives. So for AC, A is 4, C is -9. If you multiply them together, you're going to get -36. And then B is 9. And so we're really on step 3 now. Find two numbers that multiply to AC and they need to sum to B. And again, I said to do the multiplication part first. So don't worry about the 9 right now. Only look at the -36. And you can even create like a table if you want. 36. Think of two numbers that multiply to 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, and that's it. But it's negative, so one of the numbers has to be a negative number and one has to be positive for them to multiply to -36. So just look at each of these pairs. Those are all the pairs of numbers that can multiply to -36 if one of them is positive and one is negative. So go through them, and which pair would give you a sum of the number 9? Just the 3 and the 12. This one right here. If you have a positive 12 and a -3, that will give you, if you multiply them together, you'll get a product of -36. And if you add them together, you'll get +9. So I'm going to put that here and here. Actually, I don't want to put a box exactly because it's not my answer. I'll just do that. Okay, so that was step 3. We found two numbers that multiply to AC. And just double check it. If we multiply these two numbers, we're going to get AC, and they sum to B. If we add them together, we're going to get positive 9. So that's good. And so we're done with step 4. We haven't even written like any actual work over here in our workspace. And we're already on step 5. This is just all prep work. So step 5. Oh, I'm sorry. Nope, we're on step 4. All right, step 4 says break up the middle term using the two numbers that we just found. So my middle term is here, the 9x. So I'm breaking that term apart into two different parts. The first term stays the same and the last term stays the same. So I'm going to write 4x squared. But instead of writing 9x, I'm going to use these numbers here, and I'm going to write minus, and it doesn't even matter what order you do them in. You could do minus 3 first or the 12 first. So I'm going to do minus 3x and then plus 12x. And then, so that's splitting up the middle term, and then minus 9. So I split my middle bx term up into two terms. And now, look at what we just wrote. How many terms are there? 1, 2, 3, 4. We have 4 terms. So now we're at step 5. Since it has 4 terms, we can try to do this by grouping. So I look, there's no GCF. So I move on to imagine the first 2 terms grouped together, and imagine the second 2 terms grouped together. I'm going to ask myself, I'm going to look at these 2 terms here, the first 2 terms, and ask myself, do they have anything in common? Yes, they have an x in common. Put parentheses, because I'm factoring out that GCF. If we take an x out of this first term, we're going to be left with 4x, and then don't forget this minus. If we take an x out of this term here, the x divides out, and we're just left with that minus 3. Close it off. Now move to this part here. What do these 2 terms have in common? We got a 12x and we got a minus 9. They both have a 3 in common. Now, a lot of times people will just write 3. That's not correct. You have to have a sign in front of it, either plus or minus. So we're going to put a plus 3 here because they don't both have a minus. 12x divided by plus 3 is 4x. And then minus 9 divided by plus 3 is minus 3. So make sure, this is super important, make sure either a plus or a minus goes here. Because if you don't have a plus or a minus, that means it's multiplication, which is not what's happening between the first pair of terms and the second pair of terms. We are not multiplying this first part by this second part. There's a plus in between. So you need to put a plus here or you need to put a minus here, whichever one's appropriate for the GCF. All right, now we are on the part where we have like the leftover parts. So here's a leftover part and here's a leftover part. Are they the same? Yep, they're the same, which is great. That means that's our GCF, so we can pull the 4x minus 3 kind of out to the front. And if we take a 4x minus 3 out of this part here, we're left with an x. If we take the 4x minus 3 out of this part, we're left with that plus 3. Close it off, and we are done. Check your answer. Again, the way to check this one is you would just FOIL it back out, and you should get this, what we started with, if you do that. Let's do another one. Part B. So we have a trinomial. First thing we're going to ask ourselves is if there's a GCF. So do we have a GCF? Don't forget to ask yourself that when you're factoring. So we have three terms. Do they have anything in common? Yep, they got a 2 in common and they got a y in common. So write that and then put parentheses and then go term by term and divide each term out by 2y. So 12y cubed divided by 2y, that will leave us with a 6y squared. What's next? A minus sign. Don't forget that. Now 10y squared divided by 2y. Well, that 10 divided by 2 is 5. If we take a y out of the y squared, we'll just be left with 1y. And then over here, what happens if we divide 2y, a positive 2y, by 2y? 2y divided by 2y. We know that anything divided by itself is 1, so I'm going to put a plus 1. And now that 2y is just going to hang out in front the entire rest of the problem. We're not going to worry about it anymore. Now, I'm going to write my A and my B and my C, but we're using this part now because we're not going to worry about the 2y. So our A is 6, B, be careful with your sign, is -5, and C is +1. And I'm going to use my little device over here. AC goes on top, B goes on the bottom. So A times C is 6, and B is -5. And we are on step 3 right now, so we need to find two numbers that multiply to AC, and then check that they sum to B. So we need two numbers that multiply to 6. So if two numbers multiply to a +6, both the numbers either have to be positive or they both have to be negative in order for them to multiply to a +6. But notice that when we add the two numbers together, they have to come out to -5. So that tells us that both our numbers should be negative. So I'm going to think of two negative numbers that multiply to 6. And then check that they add to -5. And I'll just say that the two numbers are going to be -2 and -3. Double check. If I multiply those two together, I will get a +6. And if I add them together, -2 plus a -5, or sorry, -2 plus -3, we will get a -5. So these are good numbers. And the point of coming up with these two numbers is that we're going to take our middle term right here, and we're going to split that middle term up into two terms by using those two numbers. And the first term stays the same, the 6y squared, that does not change. And the middle term, instead of being -5y, it's going to split up using -2 and -3. So I have -2y and -3y. And then the +1 at the end does not change. Now we have 4 terms inside the parentheses. 2y hangs out in front. And so since we have 4 terms, we're going to factor by grouping. So imagine these two are going to be grouped together, and imagine these two grouped together. So we ask ourselves, what do these two have in common? They both have a 2y in common. And if we pull a 2y out of each of them, here we should be left with a 3y minus, well, 2y divided by 2y is 1. So we have a minus 1. Close it off. Now these two are a little bit different from what we've seen before because one of them's negative and one of them's positive. And they don't really have anything in common. So remember, when that happens, you can use a 1. But remember this, you have to put either a plus sign in front of the 1 or a minus sign. So which one is it going to be? Now, since, of course, I've had experience with this, I know it's actually going to be a minus, and I'll show you why in a minute. If we take a minus 1 out of this term and this term, what will happen to the signs? The signs will kind of flip-flop. So instead of minus 3y, if we do minus 3y divided by minus 1, we're going to get a positive 3y. And then for this term, if we do a plus 1 divided by negative 1, we'll get a minus 1. And that's what we wanted to happen, because now let's look at our leftover parts. 3y minus 1 and 3y minus 1. They turned out to be the same, which is what we want. And if we had used a plus here instead, they wouldn't have turned out the same. This would have been minus 3y plus 1, and we would have known we made a mistake somewhere. So then we would just switch it and choose the negative instead to correct that issue. All right, now, almost done. Because these leftover parts were the same, we get to take the 3y minus 1 and pull it out to the front, and then write the leftovers. So from here, we're going to have 2y left over. And then from this part, we're going to have this minus 1 left over when we take the 3y minus 1 out. And we are done. So we factored it because we started with minuses and pluses, and we changed it to 2y times 3y minus 1 times 2y minus 1. We converted it to multiplication. And you can check your answer by multiplying everything out. Okay. All right, let's do another one. Practice, practice, practice. All right, so here we have a trinomial. The first thing we ask ourselves is there a GCF? No GCF, so that's good. Moving on, we are going to write, let's write out what our A and our B and our C are. A is the number 8, B is the number -10, and C is the number -5. So I'm going to put AC here and B down here. So AC, 8 times -5 is -40. B is -10. And we need to come up with two numbers that multiply to this, to -40, and sum to -10. So let's write the table out again. Need a -40. So I just start with 1 and 40, then I move to 2 and 20, then I move to 3, which doesn't work. So move on to 4 and 10, then 5 and 8. 6 doesn't work, 7 doesn't work. 8 works, but we already have 8 down, so we're done with the list. Now, one of them is going to have to be positive and one will have to be negative because we have a -40 that we're aiming for. So keep that in mind. But look at these. No matter which one we choose to be positive and which one we choose to be negative, when we sum any of these pairs together, we will never be able to get the -10 that we want down here. So in this case, there is no pair of numbers that will multiply to AC and sum to B. So that's actually good in a way because we don't have to do any real work now. I'm just going to say not factorable. It asked us to factor, but it's not possible. Or sometimes you'll see it written as prime. Either way you want to write it is fine. And we're done with that one. So those are kind of nice when it doesn't work out, because then you don't have to do all the work, right? Okay, so that was the third technique, the AC method. Very, 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 very important to know that technique. So technique 1 was know how to factor out the GCF. Technique 2 was factor by grouping, and that's when you have the 4 terms and you imagine the first 2 together, imagine the second 2 together. And those 2 techniques built up to that last technique, the AC method. Now let's cover a formula that shows up all the time in math. It is the difference of squares formula. So the difference of squares formula is a very commonly used formula, and it looks like this. If you have an expression of the form a squared minus b squared, then that can always factor to a minus b times a plus b. So it's a factoring formula. I should note that. It's a factoring formula. Well, your book calls it a special factoring formula. So let's see how that works in these examples. So part A, well, first of all, it says factor. It says factor as much as possible. So what I'm going to do for part A is the first thing I always do when factoring is look for the GCF first, no matter what, just like we've done in all of them so far. So do we have a GCF here? No GCF. So now I notice that this expression, it's minus, and that's what difference means, right? Difference means minus. And it is a difference of squares. So my goal is to make this look like a squared minus b squared somehow. So I'm going to put parentheses squared. Something needs to be squared minus something else needs to be squared. Well, the minus is there already. What about the 49 is the easier place to start here. What could we put in these parentheses that when we square it, we get 49? That would be a 7, right? Because 7 squared gives us 49. How about this one here? What could we put in the parentheses that when we square it, we get 16b to the 4th? Well, with the 16, we can just put a 4 in because we know 4 squared is 16. And then for the b to the 4th, we'll put b squared. Because think about it, if you do b squared squared, that means b squared times b squared, which means b times b times b times b, which is b to the 4th. So I'm going to rewrite it like that, and that tells me that this is my a. So we got a squared minus, and this part's going to be my b. So now all I'm going to do is put it in this form here. I'm going to do it parentheses, parentheses, a minus b, and then a plus b. So my a is 4b squared, and then I have a minus, and then my b is 7, and then over here I have a plus b. So a is 4b squared plus b is 7. So this is a squared minus b squared is equal to a minus b times a plus b. Let's do another one. Do we have a GCF between these two? Yes. They both have a 2, and they both have x squared. So let's factor that out first. We take a 2x squared out of this first term, we're going to be left with x squared. Don't forget the minus. If we take a 2x squared out of this term, 8 divided by 2 is 4, and then x squared divided by x squared, they cancel out. And just like before, the GCF just hangs out in front the whole rest of the time. We don't really care about that. Now this is difference of squares. We have an x squared minus a 4, but 4 is the same as 2 squared. So we can write it like this, x squared minus 2 squared. So that tells me that this is my A and this is my B. So when I go to put it in this formula, the A minus B times A plus B, I'm going to get A minus B times A plus B. And you can check these too. FOIL them all out, multiply them all out, and you should get what you started with. Okay, so that's difference of squares. Now let's move on to another topic. Radicals or roots. So we have generally two types of roots that we might see in this class. We have even roots and we have odd roots. Even roots, that just means roots that have an even number associated with them. So first of all, these two things mean the same thing. If you have a root symbol with nothing in it, that means square root. So that's an even root because it's a 2. Over here, that is also an even root because it's a 4, the 4th root. And then over here, that's an even root as well because it's a 6th root. So you can have a square root, a 4th root, a 6th root, an 8th root, a 10th root, and so on, and those would be called our even roots. And then we have odd roots. Same thing, but just with odd numbers is all. So this is an odd root, and this is an odd root. So this is cube root, this is 5th root, and then we could have 7th root, 9th root, 11th root, and so on. So that's what it means by even and odd roots. And then here's a note. Anytime you have an even root, the inside of the even root, so say here, the part inside cannot be negative for now. Later on in the semester, we might deal a little bit with that, but just for now, we are going to say that we cannot have a negative number inside an even root. And we'll say that it's undefined. And notice that this note doesn't say anything about the odd roots. It only says inside an even root you can't have a negative number. You can have a negative number inside an odd root, though. So one example about what a root is or what it's asking you for, let's do this one here. It says, what is the 7th root of 16,384? So you might not know what the answer is, but you should understand what it's asking for. So all this is asking for is it's saying, look at the inside and then think of a number that when you multiply that number to itself 7 times, you're going to wind up with the product 16,384. So I'll just tell you that the 7th root of 16,384 is equal to the number 4. And that's because if you take 4 and you raise it to the 7th power, you're going to get 16,384. 4 times 4 times 4 times 4 times 4 times 4 times 4. That is equal to 16,384. So we did 4 times itself 7 times, and you'll get 16,384. Okay, so let's do some more examples. The 4th root of 81, what is that? So again, that's just asking you, think of a number that when you multiply it to itself 4 times, you get the number 81. So that's going to be the number 3, because 3 to the 4th equals 81. How about part B, the square root of negative 64? Well, note, this is an even root because it's the square root of negative 64, and there's a negative inside. So we're going to say that this is undefined. Because for now, no negatives inside even roots. For now. Later on, we can do something where we can have that, but for now we're just going to say undefined, okay, until we get to that point. Part C, the square root of 64. So that's just saying what number times itself will give you 64. That's the number 8. Because 8 squared equals 64. Part D, so now we have an odd root, cube root. So this time we don't have to worry about the negative inside an even root. So think about a number that when you multiply it to itself 3 times, you get negative 8. That's going to be negative 2. Because if we take the number negative 2, the whole number, and raise it to the 3rd power, we get negative 2 times negative 2 times negative 2, which is negative 8. Okay. So that's the basics of roots. And now a little more about roots. So we have these properties of radicals or roots that we want to go through. I'm not going to go too far into them. I will note that this is a list of what are called perfect squares, and anytime you have a square root, these can be helpful. So 1, 4, 9, 16, 25, 36, 49, 64, so on. Those are all perfect squares because 1 is 1 squared. Then this is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and so on. So these are all called perfect squares. And then we also have perfect cubes, same idea, except this is 1 cubed, this is 2 cubed, this is 3 cubed, 4 cubed, 5 cubed, 6 cubed, and so on. So those can be helpful when you're determining cube roots. So let's do some examples. Here we have the 4th root of 4 times the 4th root of 5. So it's the same type of root. They're both 4th roots. So if we look up here in the box, that looks like this number 3 here. So what this is saying is if you have the same type of root and they're being multiplied, then you can just kind of combine them into one root like this. So it's the 4th root of 4 times 5. So we have the 4th root of 20. Now when you get to that point, when you get to this point, you say, okay, I know what that means. That means that I'm looking for a number that I multiply to itself 4 times, and I should get the number 20. But if you think about it, there's no number that you multiply to itself 4 times that will give you 20. So we can't do anything more with that one, and we would box that as our final answer. Now part B, it's a square root, right? Square root of 150. This one, I'm going to try to break it down by using a perfect square from this list. So look at these perfect squares. Are any of these perfect squares, or I should say, is 150 divisible by any of these perfect squares? Yes, it's divisible by 25. So that's going to be helpful. So I'm going to write it as 25 times something, 25 times 6. And you want to find the largest perfect square, and 25 is the largest perfect square for this one. And then we know what the square root of 25 is, right? The square root of 25 is 5. So I can pull that out of the root, and then I just have the 6 left over, and that can't be broken down anymore. So I'll leave it like that. Part C looks a little bit more complicated, but just handle each part one at a time. So I'll focus on the root 98. So I'll write down the 8, and then the root. Now this is a square root, so I'm going to look again in this list of perfect squares. And I ask myself, what's the biggest perfect square here that 98 is divisible by? 49 is going to work. So I'm going to write it as 49 times 2. And then I have minus 3 root. Now look at the 18. Can that be broken down using one of these perfect squares? Yes, we can use the 9. 9 times 2. And again, look at how I'm writing my work. I'm not leaving out any parts. I'm not just doing root 98 on its own. I'm writing the entire expression out in every single line that I write. So now, here I have root 49. Well, that's 7. So I can pull the 7 out, but the 2 has to stay in there. Minus 3 times, again, I can pull this root 9 out. Root 9 is 3, and the 2 has to stay in there because we can't break that down anymore. Now I can multiply the 8 and the 7. I get 56 root 2 minus here, 3 times 3 is 9 root 2. And look, these are like terms actually, because they have this same root part. 56 root 2 minus 9 root 2. So we have 56 minus 9. That's going to give us 47 root 2. 56 root 2's, subtract 9 root 2's, will leave us with 47 root 2's. Okay, so that is the end of kind of the basics that we need to cover before we start with the actual course material. Again, look in your textbook, read through the just-in-time section, because I really only covered maybe about 10 topics out of the 25. They are the most important ones, but make sure that you are pretty good with the rest of them as well. Now, there is one more video on the just-in-time playlist on the YouTube channel that you need to watch, which is very important, and it's 8 minutes long, and that's entitled, I believe, Interval and Set Notation. And you need to watch that one as well before next class, because the concepts in that video we're going to use throughout the whole semester, and you're going to need to know how to write them out, because I will ask you, put your answer in interval notation. So you need to know how to do interval notation by watching that video, okay? So don't forget to do that as well. So that concludes the just-in-time review outline.